Now that we have discussed a property relating to the parallelograms, parallelograms on the same base and between same parallels are equal in areas and even the converse holding true. Now comes the question, what happens if I take the case of a triangle? Triangles on the same base and between same parallels, will the areas be equal? Is what we are going to investigate. The same theorem now investigated for triangles on the same base and between the parallel lines. Let's investigate the property for triangles. Before we do that, let's understand the triangles which lie on the same base. Let's try to just recap with what we have learned. Triangles on the same base. So here, let me try to understand how the triangles look between the same base and between same parallels. Imagine I take the same base, which is AB, just like in the previous case of a parallelogram. So with the same base AB and between the parallel line L, let's say this line is parallel to the same base AB. Now let me draw two triangles which are with the same base AB and which are between the parallel lines. So here I have a triangle, say from here to here. That's how I get one triangle which is like this. So this is the triangle, the first triangle which connects the line L with point C. So ABC is a triangle with the same base AB and between the parallel line L and AB. So let me take one more triangle in the similar manner. Let me take a triangle which is far away. So this is out here. So I have the other triangle which connects with D. So this is the triangle ABD, which is on the other side. Now as we see the two triangles, this triangle is on the base AB and the other triangle also on the same base AB. So here AB acts as the same base and they are between the parallel lines L and AB. These two lines are parallel. So triangles on the same base and between same parallels look like this. Now the investigation comes to prove whether area of this and area of this are equal. So we are going to see how we can connect the areas of these two triangles which are on the same base and between same parallels, investigating the property for triangles. So let's see the property. So triangles on the same base. So if I take the statement for same base theorem says that triangles on the same base and between same parallels are equal in area is how we understand the same base theorem. So same base theorem says that if two triangles are taken on the same base and between same parallels, they are equal in area. Is how we understand the same base theorem connected with the property. So when I take two triangles between same base and same parallels, just like this, A, B, this is the line L, and I have a triangle like this, then the two triangles must have equal areas. So area of this triangle must be equal to area of this triangle, is how we understand the areas. That is, AB being the same base, if AB is the same base, and L is parallel to AB, if the two lines are parallel and L is parallel to AB, then area of triangle ABC must be equal to area of triangle ABT. The area of the first triangle must be equal to area of the second triangle. Is how we understand the area of two triangles being equal when they are on the same base and between the same parallels. Is how we understand the property of two triangles with the same areas between same base and between same parallel lines. Now that we have discussed the property of two triangles on the same base and between same parallels are equal in area, now comes the question, what if there are more than two triangles? Well, all the three triangles will have equal area. Today's session is about triangles on the same base with the question, what if there are infinite triangles? What could be the case if I draw more than two triangles? Will all the areas be equal? Let's investigate with the property. So now that it is based on more than two triangles, let's take the case of at least 3 or 4 triangles between the same base and between the same parallels. So here I have the base AB and there's a line which is parallel to this. Now between the same parallels with the same base AB, let me take more than two triangles. Say for example, just like in the previous case we have taken two triangles, now I take many triangles between. Triangle number 2, triangle number 3, triangle number 4. So here I have totally 4 triangles as given by this. The first triangle is ABC, so totally I have 4 triangles which are taken with the same base to be listed out here. The first triangle is ABC and the second triangle is ABD, as can be seen in the diagram, and the third triangle is ABE, as seen out here. And the fourth triangle is ABF as taken here. So these are the four triangles which I have taken with the same base AB and between the parallels L and AB. So we have more than two triangles, that is four triangles out here with the same base AB. Interestingly, for all these, AB is the common base for all the four triangles considered. So according to the property, two triangles on the same base and between same parallels are equal in area. So when I take the first two triangles, the triangle area of triangle ABC must be equal to area of triangle ABD. Now when I take the case of the second and the third triangle, these two triangles are on the same base and between same parallels. So area of this must be equal to area of this. So with the second case, area of triangle ABD is equal to area of triangle ABE. Next, now since these two triangles are on the same base and between same parallels, ABE and ABF must have equal areas, as seen with two triangles on the same base and between same parallels are equal in area, the property as discussed in the previous session. Therefore, area of triangle ABE equals area of triangle ABF is what we see when I take the first two in pairs, then the second two in pairs, then the last two in pairs. So I have total three pairs which define areas of each triangles being equal. Now that each of the triangles are equal, when I combine all these six possibilities, triangle ABC equals triangle ABD, which in turn equals this, which in turn this equals this. Therefore, area of triangle ABC must be equal to area of triangle ABD, but area of triangle ABD, which in turn equals area of triangle ABE, and ABE equals ABF. Is how I see area of each of the triangles being equal. Therefore, if I have more than two triangles on the same base and between same parallels, all the triangles must have equal area, is how we understand the concept. So even if there are infinitely many triangles, they have equal areas if they are on the same base and are between same parallels. It's not restricted to two triangles, but more than two. It can be infinitely many triangles which can connect the same base with the line points on the line L, where all the areas will be equal, is how we understand. Infinitely many triangles on the same base and between same parallels are all equal in area, is how we conclude through the property.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.